10.3, we're looking at permutations. And combinations. So it's really important to understand the difference between permutation and combination. Let's start off by talking about permutation. Permutation is an ordered arrangement where two conditions follow. One, repetition is not allowed. And the second one, order matters. All right. So an ordered arrangement where repetition is not allowed and order matters. And there's also a formula for it that says NPR equals, we have a fraction which is n factorial over open parentheses n minus r close parentheses factorial. Right, and then we have combination. Combination, kind of similar definitions to permutation with an exception here. It's an ordered arrangement where, just like permutation, repetition is not allowed. But here, with this example, order does not matter. All right, so permutation and combination are very different. And even the formula for combination also is different. A combination is NCR equals, we have n factorial over r factorial times this open parentheses n minus r close parentheses factorial. Some things that are important to understand with this n and the r. In both cases, n is always the larger number. R's will be the smaller one. Same thing here. N is the larger number. R is a smaller number. So let's take a look at some examples. Once again, I think really important to understand, this last bullet for each one of them. One of them order matters, the other one order does not matter. Right, so let's take a look at some examples here. All I want you to be able to do here is to determine whether this is a permutation or combination problem. Let's go with, how about we just say a telephone number, All right, so is this a permutation or a combination? Well, with a telephone number, right, can repetition occur? Right. So, with telephone number, we know that numbers can be repeated. But we also know that order matters. All right. Why does order matter? Because let's just say your number was 2814569. That's a specific number. And this is not the same as saying 218. 5496. We can definitely see that the order matters. These two numbers are in fact different. So order matters, definitely making it permutation here. But because of the fact that our numbers can be repeated, this is key. This is telling us that it's neither permutation or combination. Once again, and it's because these numbers can be repeated. Because for permutation, repetition is not allowed. Example B. How about we say, let's say now we said a telephone number. Where numbers are not repeated. All right, then this would be a nice example of a permutation. Once again, because the order does matter. How about we have, let's say, a car race. With first, second, third place winners. All right, another example of a permutation. All right, because once again, no entry is repeated. All right, which means car 1 can't get first, second, third place. Car 2 can't get first, second, third place. Car 3 can't get first, second, third place. And here, order definitely matters. We know that first place is definitely better. Right then, second or third. How about another example here? Let's say we have a committee is needed from 6 men and 5 women. All right, this would be an example of a combination. Because no person is repeated in the committee, right? A committee is needed from 6 men and 5 women. So we're going to have a committee. We have 6 men and 5 women. no person's repeated. You'll have one man, two men, three men, four men, five men, six men. They're all different men, and same thing, five different women. And also, this order does not matter. There's no difference between men and women here, right? I mean, they're just individuals. All right, so some nice examples of permutation and combinations. Now let's go ahead and actually use our formulas to work them out. So how many ways can a president and vice president be determined in a club of 12 members? So this is definitely permutation because order matters. All right, there's a difference between the president and the vice president. All right, so we have president and vice president, which is just two people. But we have a total of the club, right, has 20 members. So these are our numbers, right? We're going to be using 20, and we're going to be using 2, and we're going to be using permutation. So we're doing NPR, which equals n factorial over n minus r, right, factorial. And as I mentioned earlier, 20 is going to be the bigger number, right? So 20 is our n, and then we have our 2 here. So we just replace 20 factorial over 20 minus 2 factorial. All right, which is just 20 factorial over 18 factorial. And in the previous video, we have learned how to work with these factorials. But also, I want you to notice that there's also NPR buttons that you can use too. I mean, if you'd like to know more on how to use those NPR buttons, just send me an email and I can add a video on that. But this answer here is 380. So a nice example there. Let's take a look at another example. How about we say, I'm trying to find some examples on your homework here. We have this one here. In a race in which 6 cars are entered and there are no ties, in how many ways can the first 3 finishers come in? So this is a race. We know with the race, order matters. All right, so this is a permutation. We have 6 cars and we want the first 3 finishers. So, all right, we have 6 cars and we want the first 3 finishers. So those are our numbers that we're going to use. Once again, NPR, right? Or in other words, 6p3 is a 6 factorial over 6 minus 3 factorial, right? Or in other words, a 6 factorial over 3 factorial. So it should be a pretty nice problem there. We get 120 with this example. Okay, moving on here. How about how many cards must be drawn? It says without replacement from a standard deck of 52 to guarantee that 6 of the cards will be the same suit. So a nice example here. Let's take a look at this one. So what do we know? We know here there's 4 suits, right? We know that there are 4 suits in a standard deck. Right? We want to suppose, right? Let's suppose that 4 times n cards are drawn. Right? We want to suppose that 4 times n cards are drawn. So, we're looking for 6 cards, right? We're looking for 6 cards here. And what we want is we're looking at this 4n, and we want to draw 6 cards. So we want to get really close to that 6, but we don't want to reach that 6. So let's just say we only actually distribute 5 cards, right? So you do 4 times 5. And once again, we do 5 because the problem says 6. So we're going to do 6 minus 1, right? That's where that 5 comes from. So that gives us 20 there. Right? So right now you've passed 20 cards. You have the potential of seeing all of them to be the same suit, or at least. This means that you have at least now 5 with that same suit. So all you have to do is just add 1 more card. Which means 21 cards must be handed out in order to get 6 to be the same suit. So this example is a nice one, one that I definitely encourage you to practice a little bit. Okay.